We're going to finish up 10.6 and look at problems involving exponential decay. A variation of the growth equation can be used as a general equation for exponential decay. In exponential decay, the original amount decreases by the same percent over a period of time. The general equation for an exponential decay is y equals c times 1 minus r to the t, where y represents the final amount, c represents the initial amount, r represents the rate of decay expressed as a decimal, and t represents time. During an economic recession, a charitable organization found that its donations dropped by 1.1% per year. Before the recession, its donations were $390,000. Write an equation that represents the charity's donations since the beginning of the recession. Our original amount was $390,000, and it's decreasing by 1.1% per year. Move our decimal 2 places left to change it to a decimal to the t. The only thing we need to do to clean it up is subtract. So we have 390,000 times 0.989 to the t. And you can put a 0 in front of there to make your decimal stand out, but it's not mathematically necessary. Next, they want us to estimate the amount of donations 5 years after the start of the recession. Okay, so we're going to estimate using the calculator and the exponent key. It's going to be down to about $369,116. This problem could have been solved graphically using GeoGebra as well. I thought you might be interested to see the difference between an exponential growth and exponential decay function. Jackson and Elizabeth bought a house when they were first married 10 years ago. Since that time, the value of real estate in their neighborhood has declined 3% per year. If they initially paid $179,000 for their house, what is its value today? Changing 3% to a decimal. And they said 10 years ago. So y equals 179,000 times 0.97 to the 10. Here's a graph that represents that situation. In exponential decay, the equation is y equals c times 1 minus r to the t, where y represents the final amount, c represents the initial amount, and r represents the rate of decay expressed as a decimal, and t represents time.